Alright, welcome to the fourth video of this differential equations playlist. First three videos we went over separable equations and some examples. Now we're going to jump into integration factor, which is a way to solve a differential equation in this form, where you have think of it as like a polynomial function, but rather instead of like an x, it's a y, and your constants are functions of x. So you can have like a function of x like x cubed times dy dx or f prime plus maybe x squared has to be a function of x or a constant times y equals another function of x. And an integration factor is an interesting way to solve this problem. What we're going to do is multiply, first you need to divide by a of x to isolate the dy dx, and by dividing a of x everywhere, we can redefine b of x over a of x as p of x. It just makes it a little more neat. And then c of x over a of x, we just redefine it as q of x. This makes it a little less writing. And we get dy dx plus p of x times y equals q of x. And what we want to do is find something that we can multiply both sides of the equation, where we are able to get something in this form. The integration factor times y, its derivative is q of x times the integration factor times that, and how it just ends up working out to be solvable. And our integration factor is going to be of the form e to the integral of p of x dx. There's something about like e to a function of x, its derivative remains somewhat constant. So by keeping something that's somewhat constant and multiplying it throughout, it somehow works out to be this. I don't know the complete proof, but hopefully it'll make more sense as we jump into an example right here. But one thing I should point out is we have this general equation, and when we multiply I of x throughout, we actually end up getting something of the form of the power rule, where g is just I of x times f prime, and f is y, and the derivative of y is dy dx, plus p of x times I of x actually turns out to just be I prime of x times y, which is f. And that's where this turns out to just work its way through. And the benefit of this is if we integrate both sides, we just end up getting I of x times y on this side, because you integrate this overall derivative, well, it just cancels out. You'll see what I mean in a little bit as we jump into an example. So first of all, we have our a of x right here. And what we need to do is isolate this y prime. And I'm actually going to write this as dy dx. We need to isolate this dy dx. So we're going to divide everything by x. So we end up getting dy dx by itself plus 2 over x y equals x cubed over x equals x squared. So now the integration factor is defined as e to the integral of p of x. And p of x is just b of x, what's multiplied by y, divided by a of x, which was multiplied by d of y. So p of x is actually just 2 of x. So let's solve that. And well, what I want to do is just take out this constant. So let's just move it down here. And we know that the integral of 1 over x is just ln of x. So we get 2 times ln of x. And we have our logarithm rules where a of ln of b actually just equals ln of b to the a. So we can actually just say this is ln of x squared. And don't forget about this e. We still have this e right there. And well, the e and the ln cancel out, so we just get x squared as our integration factor. And now I'll make some room over here so we can finish up this problem. So I of x equals x squared. And now we're at the point where we want to multiply it throughout the whole equation. And our equation is dy dx equals 2 dy dx plus 2 over x times y equals x squared. And now we want to multiply this whole equation by I of x. So we get x squared times dy dx plus x squared times 2 over x times y equals x squared times x squared. And what I want to point out is that this simplifies to 2x. And well, d dx of x squared right here equals 2x. So we can confirm that this right here is in the form of the power rule, where the power rule is g times f prime plus g prime times f, and that equals the derivative of f times g. So we're going to plug that back in. So let's continue on, and we get I of x times y, its derivative equals x to the 4th. And we know I of x is x squared, so the derivative of x squared times y equals x to the 4th. And now I just want to integrate both sides with respect to x, and well, integrating a derivative, well, that just gets us what's inside. So x squared times y equals derivative of x to the 4th plus c equals integral of x to the fourth is 1/5 x to the fifth plus c. And now we'll just solve for c. So x squared times y equals 1/5 x to the fifth plus c. We divide by x squared, we get y equals 1/5 x cubed plus c over x squared. And say we had an initial condition like y to the 1 equals, 1. We'll make it easy on ourselves. So we plug in values. And we get c equals 4/5 for this initial condition. And we'll get really messy and just write it in this little circle. So we get c equals 4/5, and we'll just finish that up with y equals 1/5 x cubed 4/5 divided by x squared equals, just 4/5 x squared. Yeah. Okay. Had to double check my algebra right there. And that's our final answer for this initial condition. Our general solution is that. Hopefully that all made sense. We're going to do some more examples